Okay, well, thank you very much for coming, everybody. My name is Jake Royal. I'm a software engineer for a company called Renaissance Re. We are a reinsurance company. And in a nutshell, reinsurance is insuring insurance companies. So insurance is a lot like investments. Diversification is the name of the game. And if a company was to buy kind of every hurricane policy for every property on Miami Beach and a Cat 4 hurricane hit them, they wouldn't have a business come Monday morning. So companies like us buy the risk off their books. To do so, we use Python. I'm on the risk modeling team at RenRe with a few other folks, and we effectively are responsible for a large Monte Carlo simulator to stochastically model the perils that we are exposed to. That could be anything from natural catastrophes such as hurricanes and earthquakes to man-made catastrophes like the CEO running off with the pension fund. And we use statistical models to model that. We use AWS as well to achieve high compute at scale, and also storage, as we have massive amounts of data that we shift around. And we are hiring at the moment. So if that is appealing to anyone on the call, please reach out to me on LinkedIn, or perhaps get my email address off the hosts if that's a thing. Okay, so why am I giving this talk? Over the last kind of 2 years during lockdown, we have grown massively as a company. I think we've grown like 20%. And particularly for kind of younger developers that are less experienced, we noticed that a lot of them don't have a whole lot of experience with writing tests. And that appears to be the case when they've either gone to college and just kind of dabbled with code to do a project or a module or something to that effect, and didn't need to write any tests or didn't want to, or you're kind of getting into programming for the first time in a different industry. You get fed up of using Excel to do something, and you use NumPy and Pandas to write 100 lines of code and say, that's fine, it works. So I'm giving this as an introduction. I'm sort of considering it a public service announcement to kind of give some experience to less experienced engineers, but hopefully I've kind of sprinkled enough nuggets of interesting information to keep the more senior people on the call engaged. Okay, so why is testing a good idea? So you can imagine in a production repo, you'll have thousands, even hundreds of thousands of lines of code. And if you decide to change this bit over here, you may not know how it affects like this piece of code over here. And so writing tests against the behaviors of your functions allows you to keep all that, keep an eye on that functionality and ensure you don't inadvertently break something. Classically, people typically use the Python standard library of unit test, which you can see here. And this kind of followed a class structure. So we'd have our test class right here, and perhaps we need to set up and pull some data in or instantiate some objects. And then we'd run our test and then tidy up our test environment afterwards with a teardown function. That's quite a bit of code, right? To write just to test this very straightforward function that I have over here to add two numbers. So what makes a good unit test? So you want them to be easy to write. You want them to be readable, so that you understand what you're actually testing. Another kind of really nice thing about having decent unit tests is if a bug does come up in production, it's a huge waste of time if you feel you have to run the entire pipeline from start to finish, or the entire application from start to finish, to figure out what's happening and what's broken in the middle. So if you have good unit tests, you should be able to pull some inputs from that broken kind of piece of your pipeline and then feed it into a unit test, which will then replicate your bug, and then you can fix it using a much smaller test case. Your tests should also be reliable. They should only fail when something about the behavior or your implementation has changed, and so the action is no longer true. You also want them to be fast, right? There's like if you have I don't know, we have repos at RenRe that have well over 1,000 tests, If that's slow, it again makes it costly for developers to introduce features to a code base and build upon that. So pytest makes life very, very easy for you. It's a very simple external library for Python. So all you require is pip install pytest. It's super simple. There's no classes if you don't want there to be. For the very simple cases, you don't even need to import pytest. And this above test here can just be written as such, right? So we just have a very simple assert, and we're calling our function here, and we're testing that the behavior is as expected. Again, a good test case kind of follows three main pieces. So firstly, we arrange. So we prepare everything needed to run our test. And this could be importing data. It could be preparing objects to feed into our test. It could be initializing a database if, as your kind of application grows, you interact with other web services or other tools around your environment. And then finally, we assert. We assert that the behavior that we're testing is true to form and is doing what we expect it to be, and what we expect it to do. So pytest, again, very clean. So this first test I've just mentioned here, we're adding 2 numbers to get 4. Then we think, okay, well, what are some edge cases we possibly need to test? So we add a negative number in here to ensure that 3 minus 1 is 2. And then we build upon that and say, okay, well, does this work for 2 negative numbers? And we get minus 24. And if we run these, it all works.
Jake, would you switch to the presentation view? Your Python?
Sure. How do I do that?
Scroll up, go to the command up to have the commands. View. And there is a appearance.
Enter presentation mode. Okay. Oh, I don't get my terminal then. No.
Well, you can switch back. But...
was it like really difficult for people to read? Not in presentation mode. Yeah, I can just bump up the font size if you want. Oh, how do I exit this now? Well, what have you done? All right, there we go. All right, let's just zoom in. Okay. So as you can kind of see, it's kind of bad form to have multiple asserts in a test. It just makes it, if one of these was to break, it kind of makes it that little bit more complicated to find out which one of your tests is failing. And so pytest has got this super cool feature, and it's probably my favorite feature of the entire library, pytest marked up parametrize. So we can do all of this, again, just calling that same assertion. And what we do is we instantiate, or we say in a string what the parameters to this test are going to be. We then follow that up with a list of the parameters we're feeding in tuples. So I've just copied these down. And what it'll do is it'll automatically run these 3 tests for me and gives me a nice little output there saying they've all passed. If we're to change one of these, it's very clear to us which one has failed. So, screen sharing, slowing everything down as normal. Cool. So we can see the second test has failed there, and we can see why. What else is another kind of cool feature about marking is you can mark the tests within your module. So you can create custom marks. So if we are pytest.mark, and we can call this, let's let's just say it's a math test. So this will work straight out the box, but you do get some errors about the custom marker not being registered. So I'll show you how to do that in a minute. So when we, oh, where's it gone? Yeah, so we're getting this kind of warning message here saying we don't have this custom mark isn't known. So this is easily fixed using a pytest.ini file. So what we can then just do is write in our mark, and just this is a math test, and then that gets rid of that. But what the power of this is you can then say, okay, I only want to run those tests, and like imagine you had, I don't know, like web server tests or something to that effect, and you're working on that piece of code, and it's correctly, you've correctly just selected those tests you're interested in at the moment. You can also do the inverse of that. So put in a string, not math test, and it should run those 16 and deselect the deselect the other one, deselect the 3 math tests and runs everything else. Sorry, I'm just going to fix that one test because that will drive me mad. 2. Cool. So another one of the marks that I find quite useful is mark.xfail. So this marker marks a test as expected to fail, and it could be quite useful for if you get a bug in production, and I don't know, some business user is shouting at you to get the fix out, and you don't have time to go around and change every test you have in the repo, but you're confident about your fix. You can mark all those tests as xfail, and what will happen is pytest will run your test. It will ensure that the test does actually fail, and you can, what I like about it is you can tell the marker the error you expect it to raise. So I have this little function here, divide, and I'm just inserting the 0 division error. And what that does is you're effectively protecting yourself, right? So you're ensuring that your behavior is only failing for kind of one specified error. And if this all of a sudden changed to an out of memory error or an index error, that would be kind of slightly more worrying. But at least if you're kind of strictly protecting for the 0 division error, you know where your issue lies, and you can readdress that as these X fails are returned to you in your pytest report. Another thing I found about pytest, which was kind of more, it was a bit easier than using unit test, was if you want to be defensive and test that certain conditions raise certain errors. So that's super easy with pytest.raises and the error of your choice. It just makes life super easy. Okay, so with marks out of the way, I'd like to talk about fixtures, which are one of the kind of most powerful things about pytest and what makes it so powerful. So fixtures effectively take care of that arrange step I mentioned earlier. So to review, arrange, act, assert. And this step basically gets all of our test resources in order. So fixtures, you can sort of think of them as essentially context managers that allow us to effectively manage our resources during testing. As your app gets larger, you're going to want to start incorporating other web services or databases into your code. And it's really bad practice to be like actually reaching out to those services, right? You don't want to be going anywhere near your production environments in your test framework. And so Fixtures allows you to fake or mock out these services you require, and allows you to kind of work around those those limitations, so you get as real an experience as possible. So it also is just really nice to kind of clean up your test environment. So I have this test here I've just called bad example, and all it's doing is taking a list of dictionaries with these 3 fields, and I'm calling sort by function, which is over here. That's actually just sorting this by the given key. So in this case, age, and I have my expected output down here. So 25, 29, 32. But again, I mean, you're not really expecting this to change immediately. So do you really need it there? Probably not. So what a fixture allows us to do is we can get rid of this. So we can effectively say list of dictionaries, and then we can just copy this out. And then we just yield those dicts, and we need to mark this as a fixture. pytest.fixture. And then all we need to do to access this is to put it in our call here. Oh, and let's change the name of this too. And then we just get this automatically. And so what's that effectively doing is it's moving the config out of your tests and kind of out of the way. So I have just put this in like just above, but best practice is to put it in a file called comptest.py, which effectively allows all these resources to be available to, it provides all these fixtures to every test in your entire directory. And it allows you to hide all that data you require to run your tests. This is also really powerful because you can have submodules within your testing framework. So you can have conf tests that override, or if you have kind of one fixture that you need in lots of different places, you can have that set kind of higher up your tree, and then make it available to everything below it. The other thing to discuss about fixtures is that you can set their scope, and by scope I mean how often they're effectively instantiated. So there are five options for this. So the default scope is fixture. So every time you run, so I've given this list of dictionaries to this function. So once this test finishes, it's destroyed. And if I was to call list of dictionaries in another test, it would reinstantiate that fixture. You can also set the scope to be a class, so it's destroyed at the teardown of the last test in the class. Module scope, and it's destroyed after the final test in the module. Package, last test in package, and then session, which is the last test in the test session. So you don't necessarily need to initialize all your data everywhere. So you can imagine that if you wanted to instantiate like a database, that could be quite costly if you wanted to do it for every single test in your module or in your test suite. So if you were to set it to module, you just fire it up once, run your test suite, and then destroy it afterwards. So fixtures are effectively controlling the granularity of your test data. And what's also nice is a fixture is only initialized when you call it. So if we were to put this fixture we just built over here, but have none of our tests actually call list of dictionaries, it would never be built. So one thing about fixtures, or which are quite powerful, is you can also chain them together. So over here on the right, and let me just zoom in a little bit over here. So as I mentioned, we make use of S3 and everything they offer, or at least a good subset of what they offer. And therefore we interact with these, and we need a way of mocking out that behavior. And so using libraries like Moto, you can accurately mock out like an S3 local client. So I have one fixture just here, which is just creating the client and creating the bucket to put things in. And then I have two data frames I've set, or two dictionaries that will be data frames I've set up here. And I'm just turning it into a byte stream and uploading it using Parquet and putting it on the client. Actually putting this presentation together, I thought I was going to be smart, and to Parquet requires a Parquet engine, and there's typically two. There's like PyArrow and Fast Parquet, and Fast Parquet is quite a bit smaller than PyArrow, so I thought, okay, let's keep the environment small as I'm doing this. But this doesn't work with Fast Parquet. You need the PyArrow engine to correctly put this into a byte stream. So trying to be smart cost me 45 minutes on Saturday. Anyway, so one extra thing I'll say is, again, the scope. So if I was to run this test logic here, or sorry, run all the tests, this file. So when we check where the S3 tests start, we see setting up S3 clients here in the first S3 test, but we don't see it in the subsequent tests. And that's again due to this module scope. So if we were to quickly change this to function, we run this again, and it should, we should see that this is being instantiated every single time, and we are seeing that. But again, if we wanted to, I mean, this is a balancing act, right? And it depends what you're trying to test. So in this first test just here, I'm testing that I have a data frame and I upload it to my mock client, and then I'm just returning it and making sure it's there by checking what the columns are in the data frame, and just because they're unique to the three files that exist there. But if I set this to module, because I've run this test before my other tests, I'm essentially updating the state of that fixture, which is bad practice. But if we again do this, and what I'm just checking here is how many objects exist in the bucket, and I've uploaded 2, or I've instantiated it with 2, and I've just run a test that puts one further on it. So when we look here, we're getting 3 across the test suite, which isn't good. So a couple of ways to do that. You either change the scope, as I just showed you, or you write a teardown function, which pytest handles really nicely. So when you instantiate your fixture, it'll run as far as your yield, run your tests, and then it comes back and runs kind of everything under the yield as well. So if we wanted to write a teardown function for this, we'd write the code here, and as I kind of mentioned, it would stop, and then once your test session has expired, it will come back and, or sorry, whatever scope you set expires, it'll come back and run those teardown functions, which is quite useful. I'm just seeing I have a Q&A, so let's see what that says. Can we use mark xfail to write permanent tests that make sure that we raise the right exceptions in our business logic, or is there a better way to test that our code fails as expected? So I would say it makes more sense to test that your given error is raised. So using pytest.raises, as we kind of saw here. And again, this is more of a marking, so I don't think you should have a lot of X failed tagged tests in your test suite. I think you should just fix your tests and bloody lights. Fix your tests and ensure that the behavior is as you expect. Okay. Coming back down here. So yeah, so these are just 2 further tests I wrote to show you that you can indeed access those 2 data frames that we've put on our mock Dest3 client. And this is the second data frame I uploaded. Okay, so another powerful piece about fixtures that I really enjoy is, so we mentioned that on our team, we have a lot of kind of pandas and NumPy work, and there's lots of data going everywhere. So as you can imagine, there's quite a few tests that do maybe a group by or a query or some form of data transform. And if you were to start writing dictionaries that you wanted to turn into data frames like I have done up here, this would be a very, very large file. So what you can do instead is have a data directory where you have all your CSV or Parquet files, and then you just have a fixture that does that heavy lifting for you. So it'll just, I've just again done pd.dataframe here, but you could just as easily pd.toCSV or read CSV, read Parquet, and then you explicitly call your fixture here and get the data you expect, run your function, and assert that it's what you expect. Similarly, just having another test here with a slightly different function. So we're just getting all the unique customers in this list. Nothing too difficult. Okay, so
How did you bring that uniqueness?
Pardon?
How did you bring that uniqueness?
Oh, so you can call, I'll show you now. So df.customer.unique, and it just returns all the unique values in your column. Yeah, this one was quite tricky actually. So to get the best customer, they're just doing a group by on the name, and so I think Mary's in there twice, and then just doing a sum and returning the customer that spent the most money. Anyway, so everything I've kind of shown you in confdest.py are kind of custom fixtures that I've kind of built myself. But we also have some pretty powerful fixtures that are built in. Some really good ones are anything that kind of captures what your system is outputting. So here I'm using cap log, which, as you probably guessed, captures the log output of the system. And there's also, if we were to just call cap here, so we also have capsys, which captures the standard error, standard out of the system, FD, file directory, and then binary versions of both those two. What's really nice about this is you can also dynamically set the level you kind of want to. So you could have one test that checks for the information that your system is outputting. So here, again, very straightforward function. It's just logging out a random number between 1 and 5, but because it's a test, I've set a seed, so it always returns 2. But you can imagine that like we're big on readability and maintainability, observability, what we call non-functionals at Renry of our code bases. And so it's just as important to be testing like what your system is telling you. And so this is just a nice way if you wanted to ensure that specific warning messages, for instance, were being raised during your system. If you had some defensive check that, I don't know, was filtering something out of a list or pulling out of a queue, you can then warn and log that the item you're removing is whatever, XYZ. And this just makes it really easy to do that. Another one I really like is Tempter. So imagine you are writing all these, you're performing transforms on all these data frames or JSON or whatever you want to do. And your system wants to effectively checkpoint what it's doing. So if you had like a DAG or something to that effect, you could possibly write out what like the results of every stage of that graph. And And although that's powerful, you don't really want to be polluting your test suite with that. One, because you don't want these massive results files to be part of your PR. That's kind of pretty bad practice. And also it just makes the data footprint of your test suite kind of smaller. So what Tempter does, it builds a temporary directory for you, that you can write out those results to. And what's kind of powerful about it is it deletes the temporary directory 3 less than the one you've written. So probably easier to show you than explain it. So if I run this test and I'm printing out my picture, this is probably pretty small for all of you. But I'm printing this out and I have pytest 29 here, and this just increments up. So pytest 25 and below have already been deleted off my system. So it just keeps you from constantly kind of overwriting files or keeping things, keeps things tidy, which is always good. You've got enough to worry about when you're maintaining large code bases. So the final pytest fixture I wanted to show you is kind of how marks and fixtures can actually interact. So in my test here, or I have a mark on this test here that has a data point in it, so the integer 2. And what you can do is you can use the request fixture to actually pull that data in for you. So you can, again, kind of parameterize certain bits and pieces of your test suite. And what this is doing is it's taking that number 2 and then just multiplying it by the number 2, just to kind of show you that this has in fact been passed from the fixture, from the mark to the fixture, and then back to the test, which is kind of clever. Okay, so again, another thing which is great about the open source community and programming is people build tools on top of tools, don't they? So pytest has got an extensive plugin library. I'm only going to go through, like, I think it's 5 or 6 of them here, but there's lots and lots. So kind of one of my favorites, kind of straight out the box, is one called pytest sugar, and this is solely a UI improvement. So if we go to the terminal here, and firstly I'll just say pytest -p, no sugar.
Bloody people in your 20s.
Well,
make that bigger.
Sorry. There we go. So what you're seeing is, like, I've run this test, and every test is just a little dot, which Nicholas just told us all his eyesight is failing, so that's hard for me to read too. And what sugar does for you is just makes it a bit easier to read. So instead of dots, you get ticks, and you also get a nice little GUI on the side as well, which runs to completion. I think it looks even better if you use a verbose flag, which gives a line to every test. And just again, the report here is, I feel personally, is a bit nicer, but it's personal preference. The second plugin I'm going to cover is pytest coverage, and coverage is a measure of how well exercised your logic is. So, like, obviously you kind of want your test suite to cover kind of every line of code. We all kind of know that isn't possible or isn't realistic. So companies typically set kind of an upper bound, be it 75 or 80, 90%. And the one thing I kind of have to say whenever you talk about coverage is no coverage means you don't have any tests. Coverage tells you nothing. And the point I make by that is just because you have a good coverage report doesn't actually mean you're correctly exercising your logic or your the behavior of your logic for failure, or covering the test case, the edge cases. But anyway, we will run this regardless. So pytest of report, and we'll just make it HTML so we can open it up and have a look. So if I go into my directory, HTML cov, and open this index file. Oh, come on. Okay, so what we're seeing here is the coverage of all our files. The only one that really kind of makes sense here is our logic file, which has all our functions in it. If we click in here, firstly, we see we have a coverage of 90%, and then it's usefully highlighted the lines that aren't covered. So it might make sense for me to write another test that tests the none case for key to sort. And then in my fizzbuzz implementation, I think I only go to 3. Yeah, so 1, 2, 3. I'm not actually testing this line or that line. So it kind of, like, it should be a prompt for you to go back and address the shortcomings of your test suite. I'm not saying everybody does, but it is a nice signpost for you to go in the right direction. Pytest stress. So I think this is pretty good for profiling, and it effectively allows you to run your suite for however long you kind of want. So you set a flag that says, well, however many minutes, seconds, hours. So if we do pytest, I think it's, sorry, I don't remember all the flags off the top of my head. Let's hope this works. Yeah, so it's just running as many times as it possibly can in 10 seconds. So this can be useful for profiling your code and possibly seeing kind of where things slow down. Or if you could possibly put a better implementation in place to make your code base more performant. So some honorable mentions, pytest.parallel. So I mentioned at the beginning of this talk that your test suite should be fast, because otherwise engineers won't want to run it. So pytest parallel allows you to run it using both multiprocessing and multi-threading. And so if you have a kind of multi-core machine, you can farm that out and hopefully get your test suite running quite a bit faster. Pytest.diff. This gives some really nice tools for checking the difference between dictionaries and kind of highlighting those differences in a much more kind of human readable state. Flake 8 is a formatter, and granted that it's usually best put in like a pre-commit Git hook, just so that the formatting of your code is kind of standard across your team. This is also a good place, or could be a good place to put it as well, so that even before you put up your PR, or it's one less step for a developer to do, right? Some of the best developers I know are lazy people, and they tell me they're lazy people. So if you can kind of chain all this together, which is quite easy using a make file or something to that effect, you can test everything, you can format it, you can lint it, and be good to go. Finally, freeze gun. One, because it's just got the coolest name, but two, it's also a very useful tool if you're ever testing datetime implementations or working with datetime objects. You probably are kind of aware that you can't stop time. Well, you can with freeze gun, but if you were to kind of check that times match across across different tests and you didn't want to mock that out, you can use a freeze gun to effectively stop the clock and make that testing quite a bit simpler. So that is effectively what I wanted to cover today. I hope you enjoyed my presentation. If you have any questions, feel free to ask or reach out. And thank you very much. Nicola, over to you.
There's Nicholas there. He's done a runner.
Warren Guinness.
Thanks, Jake.
Thank you, Kevin.
So, thank you. No, it's so it's just to sort of fix myself there. So I missed the start of it. Yeah, just give us a little bit of background about your career yourself. You work for Renaissance Re.
Yeah, exactly. So I work for Renaissance Re, and we do, as Nicola alluded to, we do sponsor, or at least we sponsored the last big Python conference by providing the accessibility. So it was a live typist for those of hard of hearing. And we are a Python shop, and we use AWS extensively as well to achieve the scale that we require to run our stochastic models. And we're modeling the exposure of our business to certain natural and unnatural catastrophes. So things like earthquakes and hurricanes, and other things, and our exposure to whether or not the deal that comes across our desk would be profitable for us or not.
Yeah. Just out of curiosity, so you've very much a mathematical background, or the team would be a mixture of mathematics and computation?
Yeah, exactly. So I pivoted hard. I studied biochemistry for undergrad. Realized if I wanted a decent paying job in that, I'd need at least a PhD. And I didn't want to be a student for another 4 or 5 years. So I went off and got a master's degree in bioinformatics, which is kind of the data science arm of biochemistry, and specializes in like cancer, genomics, that sort of thing, but all computationally, so there's no kind of wet lab involvement. And again, kind of saw, oh, well, if I wanted to continue in this field, it would be quite hard for me to kind of eke out a living, and I'd have to do a lot more study. So I sold my stats and programming background to a bank, and I went to work for Fidelity for almost 2 years, where I built anti-arbitrage trading models for them. And then after that, got hired by RenRe on their modeling team. And I think that's like, not everyone is a bioinformatician, of course they're not, but we typically hire people that have like a physics or an engineering background. My colleague is a mechanical engineer, I think he's on the call, and he was modeling the failure rate of kind of airplane engines, and then came to work for us. So we like a kind of mathsy physics background with some engineering to get in the door. But then if you're kind of more senior, that shift kind of changes slightly, and we'd expect more programming experience.
Good stuff. There's a good bit of stochastic process modeling here, which is sort of actually just not specifically here, but just in general, let's say, knowledge of probability distributions and Markov processes and stuff like that.
Yeah, exactly.
Doing theory.
Yeah, we use quite a bit of that.